How much water should, if we have 60 mils of 12 molar hydrochloric acid, how much of that should be added to make 1.5? So this is your standard dilution, all right? So when we work with stock solutions, they're usually pretty concentrated. We're going to dilute them down, especially when you're doing chemistry experiments. You don't want to be dealing with heavily concentrated caustic materials. So that would be one of your, like if you're a lab teacher or lab assistant, I'm sure you're going to be assigned to dilute these particular acids and bases when you're working with them in the lab. And of course, we'll be dealing with some of those equations. Now this again is solution chemistry. We want to know how much water would we add to this original. So this is going to be what we would commonly call stock or original solution. Let's go ahead and write the formula out. It's going to be M1. I get ahead of myself all the time. That's one thing I can change. Okay, so we have original, OG, and then final. Okay, original and final. So when it comes to dilutions, we have our molarity times our volume, and that should equal the molarity times our volume here. And for the final state, so we have original state, final state, and basically when one goes up, the other goes down. You know, this is an indirect relationship here. Okay, so we're actually taking our molarity and decreasing it quite significantly from 12 molar down to the 1.5 molar. So therefore, we'll need to increase our volume. So this is a very common dilution formula. Just look for dilution formula if you're looking it up online. That is what we're working with. All right, so we just need to fill in the blanks here. And we're actually looking for final volume, right? But hold up. Be added. We're going to add it to our original volume. Okay. So we'll see how the math's out here in just a moment. We'll have original molarity of 12, and this is HCl, right? HCl. So that's only one H. That's only one hydrogen per molecule. So we don't need to worry about coefficients out in front. What I'm talking about is right here, or right here. We just have a 1-to-1 ratio. No need to worry about that. Say if we had like H2SO4 or something like that, we would be concerned about that. We'll start with original molarity of 12, original millis of 60, and then we want 1.5, but you know, V2 is our big question of the day. I'm just trying to clean up my little parentheses here. Okay, and then we'll just divide out algebraically. 1.5, and we'll see what we get here. So 12 times 60 divided out by 1.5. We're going to get 480 mils. All right. Now, I've talked about this before, I think in a previous video. We could convert it over to liters, but then we would just have to convert it right back. And we're using the same volume types on each side of the equation. We don't need to worry about switching back and forth. We know we'll need 480 mils total. Now that's total, but we already have in the solution 60. So we actually need to add the difference. So we're going to look at the difference here of 480 minus 60, and that's what, 420 mils. So we're taking the existing 60 mils in our solution of our stock solution, our heavily concentrated solution. We're going to add 420 mils to make it a total of 480 mils, and that would give us the 1.5 molar solution. So I hope you found this helpful, and see you in the next video.